Swayam Prabha. Digital India. Educated India.
We will discuss today rank correlation coefficient and coefficient of concordance. Now, many times we need to rank. Let us say there are situations when the variables involved may not be quantitative but qualitative in nature. As an example, some properties of textile material like handle, comfort cannot be measured objectively by any instrument. So there are certain characteristics of textile product, or also you will find, as I discuss some more examples, where they are not really objectively measurable by any instrument. In such situation, what do we do? That we go for subjective assessment, which is made by some judges. And what the judges do? They assign some numbers in a scale of 1 to 10 or maybe 0 to 5. Some numbers are assigned. And these data can be used to draw certain conclusions. The rank correlation coefficient is also known as Spearman's correlation coefficient. We rank the observations first in some specific sequence. It could be in order of size, we rank something, in order of importance, or in terms of their performance, or on the basis of merit of students. We rank them, and while ranking we use numbers 1, 2, 3, 4, 5, 6, 7, 8, it can go up to n. And now we may be interested to know the degree of association between two subjectively assessed variables. What is the kind of association between them? What is the strength of the association? We will be interested to know. So as I give you some example, it will be more and more clear. The relationship between the ranks is measured instead of actual numerical values by rank correlation coefficient. The rank correlation coefficient is actually trying to measure the degree of association between the ranks. Okay, so the formula for this rank correlation coefficient is stated. We will also discuss how did we arrive for this formula. That also we are going to discuss. And if this is the formula, if we accept that this is the formula, then you see that the rank correlation, which is normally expressed in terms of RS, could be +1 when the two set of rankings are exactly same, or it could be -1 when the rankings are exactly opposite to each other. That is, highest rank value has the lowest Y rank value, and so on. So highest X rank value has the lowest Y rank value. So like any other correlation coefficient that you have studied earlier, The rank correlation coefficient also, the values may vary between +1 to -1. Okay. It does not matter whether we rank the observation in ascending or descending order. However, what is important is we must use the same ranking rule for both the variables. Ranking rule is not going to change. If two or more observations have the same value, we assign to them the mean rank. That is what we generally do. In case if it happens, so happens. Okay. Now, after stating this, now it will be more and more clear the concept if we go through an example. Now we are taking an example where, let us say, market researcher asks two shoppers to express their preferences for 12 different brands of clothing. Let us say there are 12 different brands. It could be 5, 6, 7. In this example, there are 12 brands. So in a mall, in a shop, there are 12 different brands of some items, and two shoppers are chosen who are experienced shoppers, let us say, and then we ask them that you give rankings to these brands. So we have brands like A, B, C, D up to L. And the shopper one, his ranking is variable X. And the ranking values are X1, X2, X3, X3 up to 12. 12 brands are there. Shopper 2 is ranking variable is Y, and the ranks given are Y1, Y2, Y3 up to Y12. So Xi and Yi varies between 1 to 12. Since there are 12 different brands. We need to find out the correlation between the rank variable X and Y. That is X and Y. For the same brand B, the shopper 1 has given a value X2 and shopper 2 has given a value Y2. Similarly, for each and every brand, these two shoppers have given their respective ranks, whatever they have filled. We need to know what is the correlation between the rank variable X and Y. So variable and X or Y are typical values of X and Y is shown below. So this table is basically my X data and Y data. So let us say for the brand A, the shopper X has given a value 9. Shopper B has given a value 7, the same brand. For brand B, the values are 10 and 8, C 4 and 3, like that. For the last brand L, the values are 6 and 9. So if you see these numbers are varying from 1 to 12 because there are 12 brands. So we have 1, 2, you can see that is, it must be a 3 here, 4, 5, then there must be 6, here is 6, 7, 8, you will see that this is varying from 1 to 12. So these are simple in some, not it is in mathematical form, and these are actual values. For an example, I am showing it here. And we want to know that, see, in some cases, the rankings are exactly same, like in this case. Both have given them rank number 1. These two cases, they are very close to each other, 3 and 4. In this case also very close to each other, 2 and 3. They are also very close, 11 and 12. This is exactly same, 5 and 5. So in some cases, the rankings are exactly same. In some cases, they are very close to each other. And in some cases, there may be a bit of difference between them also. We want to know what is the strength of the association of ranking between them. Okay. Now we are going to derive that formula which I have shown you earlier, derivation of the rank correlation coefficient RS. Now correlation coefficient by definition, which we have learned earlier, is this. Correlation coefficient is covariance of x and y divided by standard deviation of x and standard deviation of y. So x variable and y variable. This is what the definition of correlation coefficient. Okay. Now in the present case, we have to find out, if we look at this formula, we need to know what is covariance of x and y, and what is sigma x and what is sigma y. Where sigma x and sigma y are the standard deviation of the variable x and standard deviation of variable y. All right. Next step is, what is the formula of variance? Variance is square of standard deviations. So this formula is already known to you. Sigma xi minus x bar whole square divided by n. So this formula we all know. If we simplify this, then it can be shown that this is equivalent to 1 upon n sigma xi square minus sigma x bar square. That is a simple way it can be proved very easily. So if this is the formula of standard deviations, so to know the standard deviation, I need to know, see, xi values will be always given. But what is x bar? That we have to find out. Now the x values can vary between 1 to n. N may be 10. In the previous example, n was 12. So we write that I varies from 1 to n. Hence, what is the value of x bar? It will be 1 upon n, 1 plus 2 plus 3, up to, it will go up to n. And if this is a simple AP series, we can find out the summation of these numbers up to n, which is n plus 1 by 2. Same will be the case for y also. So therefore x bar and y bar are exactly same. Y also can take values from 1 to n, and x also can take values from 1 to n. So whatever is the x bar, same thing will be y bar. Therefore we write x bar equal to y bar, and that becomes n plus 1 by 2. So if n is 12, the x bar y bar will be 12 plus 1 by 2, 13 by 2, that is 6.5. That will be the value. Okay, so this way we can find out the value of x bar, and we need to know x bar in order to calculate variance, because x bar is coming here. Next is, so if I go for standard deviation, I also need to know this value, 1 upon n sigma xi square. So now if this is the formula for standard deviation, x bar square is simply square of n plus 1 by 2, because this is what is x bar. So square it. And now we need to know the summation of these numbers starting from 1 to n, but we have to square them, because summation is sigma xi square. So xi values are starting from 1, 2, 3, 4, 5, 6 up to n. So these are all to be squared and they have to be added. And if we do so, for this, it can be shown this is n into n plus 1 into 2n plus 1 divided by 6n. And the x bar square is whatever is stated here. And if we go for further simplification of this, we go step by step. So you can take n plus 1 common. So we are left with this. And then you go for further simplifications, you work it out, and you will finally arrive at this value, n square minus 1 by 12. So sigma square x, or the variance of x, is n square minus 1 by 12. That is the variance of x. So what is going to be the variance of y? Variance of y also will be exactly same. That will not be any difference. So x bar and y bar are same because the numbers involved is from 1 to n. Similarly, the variance of x and variance of y also will be exactly same. They will not be different. These numbers will not change. So variance of x and y both are basically same because the numbers involved for the calculation of sigma square x and the same number also will be, there will be same number for the calculation of sigma square y. So therefore the variance of x and y will be exactly same. But in general, xi and yi are not same. For a given brand, the corresponding xi value and yi value are not same. They accidentally they may same in some cases because we have seen earlier. In few cases, they are exactly same cases. In the rest of the cases, they are different. So in general, they will not be different from each other. Let us say we find the difference di, which is xi minus yi. So for each and every brand, we find out what is the corresponding differences in the ranking between the two people. So that is xi minus yi. And now what we do? We write the same equation, we write xi minus x bar minus yi minus y bar. So from xi, I am subtracting x bar, and from yi, I am subtracting y bar. But from y bar, if I subtract y bar, and from xi, if I subtract x bar, they are still same because x bar and y bar are same. So instead of writing yi minus x bar, we are writing yi minus y bar. So after doing this, we go to the next step, we square it. We find out what is di square and what is the summation value of di square. Di represents the differences between the rankings. So if this is my di square is sigma xi minus x bar minus yi minus y bar whole square. And this is a formula of a minus b whole square. So now we have to go for simplification of this. We straight away write the very basic algebraic equations a minus b whole square. So we'll write sigma xi minus x bar. Sigma is common, so I can write a square in front of it, sigma. I write y bar whole square in front of it, sigma. And again here I write 2 into xi minus x bar into yi minus y bar. Here also you should write, I think it is missing, the sigma sign also should come here. Now we divide by n. If we divide by n, 1 upon n di square equal to, you divide all the terms by n. So after dividing by n, why I am dividing by n? By doing so, I can write sigma xi minus x bar whole square by n as sigma square x, because that is the variance of x. The second term becomes the variance of y, and the third term becomes 2 into covariance of x and y. If we look back and study the formula of covariance, this is the formula for covariance. This is 2 covariance of x and y. 2 is a constant, I take it out. What is left? Sigma xi minus x bar into yi minus y bar by n. That is the formula for covariance of xy. Now come the next line. This is equal to sigma square x, sigma square y, minus, now it is, we are writing the covariance of xy. I am replacing it by the formula. By definition, RS equal to covariance of xy by sigma x into sigma y. So covariance of xy equal to multiplication of these two, RS into sigma x into sigma y. So it will be 2 RS sigma x sigma y. So covariance is actually substituted or replaced by RS into sigma x sigma y, because this is by definition is the formula for correlation coefficient, which we have learnt it earlier. But correlation coefficient basically, it is basically the ratio of covariance of xy divided by the sigma x and sigma y. So if we know this, next step will be, I will change sigma square y by sigma x, because they are same. So I can write 2 sigma square x and sigma x into sigma y, because sigma y is equal to sigma x. So I can write 2 RX into sigma square x. Therefore, then I take 2 sigma square x common. What is left is 1 minus RS within bracket. And therefore, I continue this, that this is, we have seen it in the previous slide. So if we go for, we need to now write RS in terms of the rest of the variables. So from here I can write 1 minus RS equal to sigma di square divided by 2 into n into sigma square x. Just from here it will come. And then from here you go to the next equation. So RS will be in term, if we write 1 minus sigma square di square by 2n sigma square x, and di square 2n, and what is sigma square x? That we have calculated earlier. This is which we have done it. X sigma square x equal to n square minus 1 by 12. So we replace sigma square x by n square minus 1 by 12. Now go for one more step. It becomes 12 by 12 sigma d square 2 into n square minus 1. So you can now 2 2 and 12, it will cancel, will be left with 6. It will be 1 minus 6 di square divided by n into n square minus 1. So that is correlation coefficient in this case. And we call it correlation coefficient between the ranks. So we call it rank correlation coefficient. So the formula may look little different, but actually whatever by definition we say this is my correlation coefficient, and whatever formula is used to describe the strength of relationship between two variables x and y, exactly same thing also we use it here. And we get this particular formula, that is RS, rank correlation coefficient is 1 minus 6 di square, where di is always what? The difference between the ranks. So we need to find out this first. So calculation of rank correlation coefficient ultimately becomes a very, very simple exercise. We only need to know what is di, then you need to know what is di square. After that, n value is anyway given, the number of objects or items or whatever is given order. So it becomes very, very simple and easy to solve. So understanding should be clear. Now solution is actually easier. So we are going to solve two problems here in this case, one or two problems. Let us see. The first problem is, the following table shows the ranking of 10 students according to their performance in the classwork and their final examinations. Okay, so rank based on classwork for all these students from starting from A to J. How many students are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 students are ranked. On the basis of classwork, which is done throughout the semester, the rank values are given. 2, 5, 6, 1, 4, 10, 7, 9, 3, 8. And when we go for ranking on the basis of the score they have obtained in the final exam, the rankings are now stated in the second row. So you can see the ranks now. A has a rank 2 in classwork and number 1 in the final examinations. And D is just opposite of A. 1 on the basis of classwork, but 2 on the basis of final examinations. So you see, for some people the ranks are very close to each other, but here I don't find any rank which are exactly same both in the classwork and in the rank obtained in the final exam. But for many cases they are very close to each other. 1 and 2 difference is 1, 3 and 4 difference is 1, 8 and 9 difference is 1. Anyway, so these are the ranks. So what we will do next to calculate the rank correlation coefficient? This is the formula. We need to know what is di and what is n. So n value is 10 because there are 10 students. So what is my di and what is my di square? So I first find out what is rank difference di, which is in this case 2 minus 1, 1, 5 minus 6. So 5 minus 6 will be how much? It will be minus 1. 6 minus 4, 2, 1 minus 2, minus 1, 4 minus 3, 1, 10 minus 7, 3, 7 minus 8, minus 1, 9 minus 10, it will be minus 1. So like that you get some positive values, some negative values. But after this we need to do this. We have to go for squaring them. So we square them. So all the negative values whichever they are, all they get converted into positive values now. So now after squaring, these are the data. Now we find out what is the sigma di square. This value, if I add them, 1 plus 1 plus 4 plus 1 plus 1 plus 9 plus 1 plus 1 plus 4 plus 1. If we do it, we get the figure 24. So now everything is known to us. We know what is the value of n. N is 10. So now everything is known. So we find out, we substitute these values in this formula. Formula is this. Substitute these values. We arrive at this figure 0.855. That is the rank correlation coefficient. So it is a good, you can say, correlation because it is close to 1. And it is also positive. Okay. We go for another example of handle and comfort values. So handle and comfort values also difficult to measure by any instrument. So we go for some kind of qualitative judgment we make. So in this case, there are suppose 7 different fabrics are there. 1, 2, 3, 4, 5, 6, 7. A, B, C, D up to G. And the handle rank is given. So one property, let us say, is handle. The other rank is comfort rank is also given. So we want to establish whether how close the handle and comfort ranks are. So here is the data which is available. N value is 7 because there are 7 fabrics. First we find out the rank differences, DI values. 7 minus 7 is 0, 3 minus 2 is 1, 1 minus 1 equals 0. So when it is 0, that means both are ranked same. So these are this entire row is giving you the differences. And now we go for we have to find out what are the square values of this and then add them together. So the DI values are given here. Now DI square, sigma DI square equal to what? Square of 0 is 0, square of 1, square of 0, square of minus 1, square of minus 2, square of 1, square of 1. So these values are the square values of D. If we add them together, we arrive at the figure 8. And now the formula was given earlier, the same formula we use, and we substitute the value of n and sigma di square, and we get a figure 0.857. So that is the answer to these questions. This is the correlation between them. Significant test for the rank correlation coefficient. Is there an association between handle and comfort? If this question is raised, then the null hypothesis and alternative hypothesis could be written as null hypothesis, there is no association between them. So alternative hypothesis will be opposite to that. There is an association between the two variables. So one is no association, the other one is there is an association. So no word is here in H0. Okay. It is a two-tailed test. If the null hypothesis is rejected, the association could be positive or negative. For n equal to 5 to 10, the critical values that calculated RS must exceed to be significant is shown in the table below. So here is a table which is available that shows the critical values for n value varying between 5 to 10. So somebody has, some mathematician has developed this table, and we are directly going to use it straight away as long as n lies between 5 to 10. So here the values are from 5 to 10. So critical values of RS for 5% level of significance, these are the corresponding values. And for 1% level of significance, these are the corresponding values. So like we earlier found out the Z values, and then we used to consult a table. What is the value of Z or value of T or value of chi-square or F? Similarly, this table we have to use now. And the values are given, and this is valid for n values lying between 5 and 10. So calculated value of R square is how much? 0.857. And critical value of RS at 5% level of significance, if we see, for n equal to 7 is how much? This is the value, 0.75. So what we see, that calculated value is more than this. So association is significant at 5% level, and therefore the null hypothesis of no association is to be rejected. That is the conclusion we draw. So this is how we use the formula. We can calculate the value of RS, this rank correlation coefficient, and also if we can test at two different level of significance, 5% and 1%, provided and we have to also, there is a restriction that the value of n should lie between 5 to 10. If it is 12, then obviously this table cannot be used. If it is 3, then also the value cannot be, this table cannot be used. Okay, so this is all about the rank correlation coefficient. So in a way, it is not too different from the correlation coefficient that we have learned earlier. The formula is basically same, but the form of the final formula is little different. It is all based on the difference between the two variables, that is di. Okay, so now the other topic that we are going to discuss is coefficient of concordance. Now these are because we are choosing this thing because these are very relevant for textiles. Many a times we have to judge the fabric quality by looking at it, by feeling it, and there may be many fabrics, and wherever there is a buyer seller made, they will try to judge the quality of the fabric based on, they will judge subjectively. Now there may be experiments where more than two set of rankings could be there also, and we can have just not two judges or two people ranking. There may be multiple people also, many more than two. Example, ranking of a design competition. Suppose there is a design competition for a particular type of dress. If someone has designed some dress material, some dress product, some clothing items, and let us say the design A, design B, design C up to J is there. Or you can also imagine that students A, B, C, D, F, up to I, J, they may be students, they have designed, there are 10 different design students are here. And how many? Here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then each one of them has been judged by 4 different judges. There is a jury. So jury members are there, and there are 4 people are there. They are judging, and these are the rank values that they have given. So for each design item, the rank values for 4 different judges are given. So this data is available. Now we need to know what is the degree of association between the 4 judges in ranking the products. Now coefficient on concordance has a formula, this. Now this formula we are not going to derive. We accept the formula as it is. This is the correct formula and we'll make use of this. So the formula is 12S. What is S? That is stated here. So S is Ri minus R bar. That means R bar is the average rank, and this is the difference between Ri and the average rank, individual rank value and the average value, and square them, sigma square, the square, and then sum them up. We call it S. Like sigma xi minus x bar whole square. When we divide it by n, it becomes standard deviations. Where sum of ranks given to the ith item is Ri, mean of these ranks is R bar. Number of judges are smaller, and number of items ranks are n. So if we look back the previous example, n is 10 and R is number of judges. There are 4 judges, so R value is 4, and S value we need to basically calculate. So the formula also in this case is quite easy to use, very simplistic formula, not very complicated, and the calculation part is also not very difficult. So the value of W ranges between 0 to 1. When all ranks are same, that means complete agreement between the judges, the value of W will be 1. So all the judges are saying that yes, this person or this particular design is the best. So everybody is giving rank value 1, 1, 1, 1, 1, all 4 judges. If that kind of hypothetical situation, if we if we imagine, in that case the W value will come to be 1. That is the degree of association in the rankings between the judges. If the rank values or rank differs too much, W will be closer to 0. So more agreement is there, it will be close to 1. The less and less agreement is there, it will go downwards and will approach 0. Now we start with the previous example. So these are the different designs, and corresponding qualitative rank values are also stated here. So first of all, what we find out is what is the rank sum. So rank sum is, in this case, you see, I add this plus this plus this plus this. It is 29, 6, 30. These are the rank sum. Then I go for Ri minus R dash. So we need to know what is R bar. So R bar we have to calculate. If we go for R bar calculation, that figure will come to be 22. And therefore, when we Ri minus R bar, if I do it, these values will be 7, 16, 8, because R bar is going to be 22. So 22 minus 22, it will be 0. So these differences are stated in this particular row, and this here, it is square of all of them. And now we find out what is the value of S. All these square terms have to be added. So we add 49 plus 256 plus 64 plus 0 plus 100. If we add them, we arrive at this figure. And small r is 4, small n is 10. So W is, the formula is given. I substitute the values and we get a figure 0.679. That is the level up. You can say this figure indicates the level of agreement between the judges, 0.679 or let's say 0.68. Because in some cases, the values are very close to each other, like let us say for E. 4 judges, the values are between 2 to 4. There is not wide difference between them. But there are situations where you may find very large difference. In this case also, you see the difference is not much. 1, 1, 1. One judge has given 3. But in some cases, see, in this case, somebody is rating it at 2, another person is giving a value of 8. So almost opposite. Someone has said it is very good. It is next to number 1. And another judge is giving a value 8 to it, almost on the other end. So there is a lot of disagreement, particularly for the design B. So this is what is going to happen, because this is a subjective assessment. And this is very common. So in many situations, we go for this kind of assessment, no, that judges will going to assess. Suppose there is a debating competition going on, 5, 6 students are debating, that will be a set of judges, 3, 4 people. So they will try to rank them by giving some numbers. And then if somebody is interested to do the statistical calculation, they can find out what is the level of agreement between the judges. So those kind of things we can do. So and this can be, there are many applications where we can find that this is what is required. So in textile also, for it could be design of different types of fabrics or different types of dresses. So many textile products also we need to sometimes rank based on in a qualitative basis. And with that, we close this particular session on rank correlation coefficient and coefficient of concordance. You have seen that now that the calculation part is really very simple. Once the data is there, the calculation is very simple. One needs to remember the formula, and we can or she can use it. And even you do not need a computer to do the job, it can be done very fast manually also. But anyway, Excel can be also be used, and very quickly one can find out the values. Okay, with this we close today's lesson, and I'll meet you in the next class and we'll discuss a new topic. Thanks.